In this video, we want to learn how we can add, subtract, multiply, and divide complex numbers. Our first example is this: 2 plus 3i times by 3 plus 4i. To multiply two complex numbers by each other, simply multiply the brackets by each other, like the normal expressions in algebra. 2 times 3 would be 6, so first we multiply 2 by 3, then we have 6. 2 times 4i, we have 8i. We multiply real part, 2 times by 4 is 8, so we have 8i. Then we multiply 3i by 3, then we have 3i times 3, which is 9i. And finally, we have to multiply 3i by 4i. 3 times 4 is 12, I times I is I to the 2. So we have plus 12i squared. Now, let me remind you about complex numbers. What is I? We know that I is defined as a square root of negative 1. We have defined a square root of negative 1 to be equal to I. Now from this, if we raise both sides to the power of 2, what is I to the 2? I to the 2 equals negative 1. Because when we raise this to the power of 2, the power of 2 and radical cancels, so I to the 2 is negative 1. And we can use this here to simplify 12i to the 2. I to the 2 is negative 1. So 12i to the 2 is like negative 12, because 12 times negative 1 is negative 12. So in this expression, we can simplify 12i to the 2 in this form. We keep 6 here. 8i plus 9i is 17i. 12i to the 2 is negative 12. Negative 12 plus the 6 that we have at the first term. Negative 12 plus 6 is negative 6 plus 17i. And this is the answer of multiplying these two complex numbers here. Before we move to the next example, please pay attention. When we multiply, divide, subtract, add complex numbers, your final answer always should be in the form of a plus bi. Please pay attention to this. Your final answer should be written in the form of a plus bi. And if you pay attention to this final answer for this question, the negative 6 is a, and 17 is b, and so our answer is in the form of a plus bi. And as you know, we say negative 6 is the real part of the complex number, and 17 is the imaginary part of the complex number. Let me remind you about the complex number. When we have a complex number like z in the form of a plus bi, this complex number has two parts. A real part, which is a, so this is the real part of the complex number, and b, which is the coefficient of I, is the imaginary part of the complex number. Now we have this example, 5 plus 3i to the 2. We know that when we have an expression to the 2, basically it means that multiply that expression by itself. So 5 plus 3i to the power of 2 is the same as 5 plus 3i times by 5 plus 3i. If you are familiar with this identity, a plus b to the 2 is a2 plus 2ab plus b to the 2. You can simplify this with the aim of this identity. And probably you can find the answer a little fast. But if you are not familiar with this, and you don't remember this identity, simply multiply the two brackets by each other. So, similar to the previous question, we multiply 5 by 5, then we have 25. 5 times 3i would be 15i. Then we multiply 3i from here to here. 3i times 5 would be 15i. And finally, 3i times 3i is 9i squared. Remember again, I to the 2 is negative 1. So whenever you get a term with I to the 2, you can replace I to the 2 with negative 1. So this term is like negative 9, because 9 times negative 1 is negative 9. So if we simplify this answer, we have 25 minus 9 is 16. 15i plus 15i is 30i. And this is our answer for this question. And please pay attention again. This answer is in the form of a plus bi, which a is 16, b is 13. Now look at this. 1 plus 2i to the power of 3. So we have to multiply 1 plus 2i times by 1 plus 2i times by 1 plus 2i. Here, to raise this to the power of 3, either you can use this identity, which a plus b to the 3 is equal to a to the 3 plus 3a to the 2b plus 3ab 2 plus b to the 2. But probably you don't like to memorize this identity, so let's multiply the brackets by each other directly. First, we multiply the first two brackets. The order of multiplications of the brackets doesn't matter. You can multiply the last two brackets first, then multiply by the first one. But normally we start from the left in the operation in math, so because it doesn't matter really, so we start by multiplying these two brackets by each other. 1 times 1 is 1. 1 times 2i is 2i. Then we have to multiply 2i in this bracket. 2i times 1 is 2i. And 2i times another 2i would be 4i squared. And we leave the last bracket. For 4i to the 2, we know this is negative 4. Negative 4 plus 1 is negative 3. So here we have negative 3 plus 4i times 1 plus 2i. Now multiply the brackets again. Negative 3 times 1 is negative 3. Negative 3 times 2i is negative 6i. 4i times 1 is 4i. And 4i times 2i is 8i to the 2. 8i to the 2 is negative 8, plus that negative 3 is negative 11. Negative 6i plus 2i is negative 2i. And this is the answer of this question. 1 plus 2i to the power of 3 is equal to negative 11 minus 2i. Now, here we want to do a division. We want to divide 2i by 1 minus I. For dividing two complex numbers by each other, the technique that we use is this. We multiply numerator and denominator by the conjugate of the denominator. And for a plus bi, the conjugate is a minus bi. Or for a minus bi, the conjugate is a plus bi. So, what is the conjugate of a complex number? The conjugate of a complex number is another complex number that the difference between these two complex numbers is the sign of the coefficient of I. For example, when we have 3 plus 4i, its conjugate is 3 minus 4i. And the conjugate of this number is that number. So, here, in the denominator, we have 1 minus I. So we multiply numerator and denominator by the conjugate of 1 minus I. What is conjugate of 1 minus I? The conjugate of 1 minus I is 1 plus I. And now we multiply numerator by numerator, denominator by denominator. If you multiply numerator by numerator, 2i times 1 is 2i. 2i times I would be 2i squared. What about denominator? What is the result of 1 minus I times 1 plus I? Simply you can multiply these two brackets by each other. But attention, here, if you remember this identity, a minus b times a plus b is a to the 2 minus b to the 2. So here you can use that identity, and so the result is 1 to the 2 minus I to the 2. This is a little faster than multiplying the brackets by each other normal way. And remember, I to the 2 is negative 1, so this equals to 1 to the 2, which is 1, minus negative 1. And so the final answer is 2. So the denominator is 2. But is this really the best way to multiply these two denominators by each other? No. Please pay attention. Let me show you a faster method to multiply a number by its conjugate. Attention, please. This number is the conjugate of this number, or this number is the conjugate of this. When you want to multiply a number by its conjugate, there is a shortcut for multiplying them by each other. How we can get this answer right away without doing any calculation like this? When you want to multiply two numbers, two complex numbers that are conjugate of each other, the easiest way is this. Always the answer is the real part to the power of 2, so 1 to the 2, plus, what is coefficient of I here or here? Just the coefficient. Coefficient of I is 1 or negative 1. The answer is always this. Real part, which is in this case 1 to the 2, plus the coefficient of I to the 2. And coefficient of I is either 1 or negative 1. And it doesn't matter 1 or negative 1 to the 2, because we raise it to the 2, at the end it would be positive. So the answer is 1 to the 2 plus 1 to the 2, or negative 1 to the 2. It doesn't matter. And it equals to 2. So, for multiplying two numbers that are conjugate of each other, you don't need to really do anything. Just raise the real part to the 2, and then plus coefficient of I to the 2. For example, let's do an example here. What is 3 plus 2i times 3 minus 2i? Can you find this in your head without writing anything? The answer is 3 to the 2 plus 2 to the 2. Look at this number and this number. Raise both of them to the 2 and add them to each other. 3 to the 2, 9, 2 to the 2, 4, 9 plus 4, 13. Yes, the answer is 13. Back to our question. When we multiply denominator by denominator, the answer is 2. Now, let's simplify numerator. In numerator, we have 2i and 2i to the 2. 2i to the 2 is negative 2, because we know that I to the 2 is negative 1. So the numerator is basically negative 2 plus 2i. Always it's better to write the real part first, then the other part of the complex number. So negative 2 plus 2i. Or you can write 2i minus 2. But this is the better form for writing a complex number. And we have in denominator 2. Now if we divide numerator by denominator, negative 2 divided by 2 is negative 1. 2i divided by 2 is I. So the answer of this division is negative 1 plus I. Now here we have another example of division or dividing two complex numbers. If z1 is this complex number and z2 is that complex number, divide z1 by z2. So we want to find what is z1 over z2. z1 is 4 minus 3i, z2 is 3 plus 2i. And we know that for dividing two complex numbers, we multiply numerator and denominator by the conjugate of the denominator. What is conjugate of 3 plus 2i? 3 minus 2i. So we multiply numerator and denominator by 3 minus 2i. First, we calculate the denominator. What is 3 plus 2i times by 3 minus 2i with the shortcut method that we discussed in the previous question? If we multiply denominator by denominator, 3 plus 2i times 3 minus 2i, it would be 3 to the 2 plus 2 to the 2, and it is 13. Easy. Now multiply the numerator by numerator as usual. 4 times 3 is 12. 4 times negative 2i is negative 8i. So first we multiply 4 by 3, then 4 by negative 2i, and now negative 3i times 3 is negative 9i. And finally, negative 3i times negative 2i would be plus 6i to the 2. 6i to the 2 is negative 6. Plus that 12 in the beginning, we have 12 minus 6, which is 6. Minus 17i all over 13. We can write this in the form of 6 over 13 minus 17 over 13i. Remember this, always we like to write our answer in the form of a plus bi. Here this is a and this is b. A is 6 over 13, b is negative 17 over 13. Here we have a division, a multiplication, so we have lots of things to do here. We have to divide 5 by 1 plus 2i. For that, we have to multiply numerator and denominator by the conjugate of denominator. Maybe you are thinking, why not given denominator 1 to here and do a common denominator? That method also works, but probably you have to do a little more algebra. So the easier way is to first divide 5 by 1 plus 2i, and of course multiply negative I by the 2 plus I, simplify it, and then simplify the total expression. So here we start with dividing 5 by 1 plus 2i. To divide 5 by 1 plus 2i, we multiply numerator and the denominator by 1 minus 2i, the conjugate of denominator. And of course, we multiply this in the bracket. Then we have negative I times 2, which is negative 2i. And negative I times I is negative I squared. In numerator, if we multiply 5 by 1 minus 2i, we have 5 times 1, 5, minus 10i. What about denominator? What is the result of 1 plus 2i times 1 minus 2i? The answer would be, if we calculate this in our head, the answer would be 1 to the 2 plus 2 to the 2. 1 to the 2 is 1, 2 to the 2 is 4, 4 plus 1 is 5. So now we know that the answer of the denominator is simply 5. Try to do these type of calculations like this. You don't need to write everything. It takes so much time. Negative 2i, don't forget we have negative 2i, minus I to the 2 would be minus 1 plus 1. Now divide the terms in the numerator by 5. 5 over 5 is 1. 10i divided by 5 is negative 2i, minus 2i plus 1. The real with real, we have to add real to real. 1 plus 1 is 2. Negative 2i minus 2i would be negative 4i. And this is the answer of this question. Here we have another question, a division. But when we look at the denominator, we notice that we have I to the 6, I to the 13. What we have to do with those terms? Remember that I to the power of 2 is a negative 1. This is a very useful rule that we can use for these expressions in the denominator, I to the 6 and I to the 13. But how? I to the 6 is basically I to the 2 to the 3. What is I to the 2? Negative 1. So this equals to negative 1 to the 3. And negative 1 to the 3 is negative 1. So now we know that I to the 6 is negative 1. What about I to the 13? I to the 13, because the power is odd in this case. If it was something like 10, 12, 14, we can do similar to I to the 6 or I to the 2 to the another power. But I to the 13, because the power is odd, you have to separate one I. And then we have I to the 12. I to the 13 basically is I times I to the 12. Because if we add the powers, it's again I to the 13. Now, we leave I by itself. I to the 12 is I to the 2 to the 6. 2 times 6 is 12. I to the 2 is negative 1. Negative 1 to the 6 is 1 because the power is even. Negative 1 to the 6 is 1. So all of this is 1 times I, it equals I. Now let's back to our question that we had. We want to simplify this expression. So we have 4I over 2 plus I to the 6. But now we know that I to the 6 is negative 1. So plus negative 1. I to the 13 is I plus I. So we have 4I all over 2 minus 1 is 1. So 1 plus I. Now we have a simple complex number in numerator and another complex number in denominator. How we divide two complex number? Remember, we multiply numerator and denominator by the conjugate of that complex number. What is conjugate of 1 plus I? Its conjugate is 1 minus I. So we multiply numerator and denominator by the conjugate of 1 plus I, which is 1 minus I. Multiplying numerator by numerator, denominator by denominator, then we have 4I times 1 is 4I. 4I times negative I is minus 4I squared. What about denominator? What is 1 plus I times 1 minus I? Use the shortcut method. When we multiply two complex numbers that are conjugate of each other, we don't really need to multiply them by each other in the normal way. The answer is always the real part, which is 1. The real part is 1 to the 2. And what is coefficient of I? It is also 1. 1 to the 2. So the answer of 1 plus I times 1 minus I is 1 to the 2 plus 1 to the 2. So in total it is 2. Now, in numerator, we have minus 4I to the 2. I to the 2 is negative 1. Negative 1 times negative 4 is 4. So in numerator, we have 4 plus 4I divided by 2. 4 divided by 2 is 2. I divided by 2 is 2I. And this is the final answer of this question. Now look at this question. If z equals a plus bi, then find real part of z to the 2 and imaginary part of z to the 2. So basically we have to find z to the 2 and then we have to figure out what is the real part and the imaginary part of the answer. Z is a plus bi. What is z to the 2? Simply raise both sides to the 2 to find z to the 2. So it should be easy. Z to the power of 2 is a plus bi to the 2. What is a plus bi to the 2? A plus bi times a plus bi. If we multiply the two brackets by each other, a times a is a2. A times bi is abi. Bi times a would be again abi, because finally we have to multiply a by b. Bi times a is abi. So we have basically 2 abi. And finally, bi times bi is b2 i2. I2 is negative 1. So b2 i2 is negative b2. So it's better now to write the answer in this form. a2 minus b2 plus 2abi. Why I prefer to rewrite the answer in this form? Because I prefer to separate the real part and the imaginary part. a2 minus b2 is the real part of the answer, and 2ab is the imaginary part of z. So what is the answer of real of z to the 2? Real of z to the 2 is a2 minus b2. What is imaginary part of z to the 2? 2ab. Please don't make me this mistake to think that 2abi is imaginary part. No, when we talk about imaginary part of a complex number, we talk about the coefficient of I. Do not include, please, I in your answer. What is imaginary part of z to the 2? Only 2ab. Look at here. What is real of z? A. What is imaginary part of z? B, not bi. We have another question here. Suppose z is x plus iy. Find real of 1 over z, imaginary of 1 over z. So basically we have to find reciprocal of z, 1 over z. And then we have to find real and imaginary part of reciprocal of z. 1 over z, 1 divided by z, is basically 1 divided by x plus iy. And remember, when we want to divide a number, complex number, by another complex number, always we multiply numerator by and denominator by the conjugate of denominator. And please pay attention. Maybe you are thinking this is not a complex number. Yes, this is also a complex number. 1 is a real number and also is a complex number, because you can think 1 as 1 plus 0i. So 1 is a complex number that its imaginary part is 0. Now we multiply as usual, numerator by numerator, denominator by denominator. 1 in numerator multiplied by x minus iy is x minus iy. What is x plus iy times by x minus iy? It would be x to the 2, real part to the 2, plus imaginary part, which is y to the 2. So x plus iy times x minus iy is x2 plus y2. Real part to the 2, imaginary part, which is the coefficient of I. Iy is basically like y times I. The imaginary part is y to the 2. You don't really need to waste your time and multiply the brackets, the expressions in the denominator by each other. You don't need to multiply term by term. Don't waste your time like that. Is this the final answer? Yes, 1 over z is equal to this. But remember, I have mentioned this several times. Always we want to write our answer in the form of a plus bi. Is this answer in the form of a, which is a real part, plus a coefficient times by I? No, it's not. So we have to try to rewrite this answer in that form. How we can do that? Simply separate the terms in numerator and divide them by the denominator. So we can write this answer in the form of x over x2 plus y2 plus negative y over x2 plus y2 times yi. Attention please. We have two terms in numerator. X divided by this, we get this expression. And also, we have negative iy divided by x2 plus y2. Negative iy divided by x2 plus y2, we can write it in the form of negative y over x2 plus y2. If we multiply this I in numerator, we have same thing. But why I wrote it in this form? Because I prefer to have my imaginary part separated from I. Now, I can answer this question easily. What is real of 1 over z? Real of 1 over z is x over x2 plus y2. What is imaginary part of 1 over z? Attention, this is 1 over z. What is imaginary part of 1 over z? Yes, it is exactly negative y over x2 plus y2. I hope by watching this video you have learned how to add, subtract, multiply and divide complex numbers, and also you have learned how to write your answers in the complex numbers in the proper form, and now you are a little familiar with real parts, imaginary parts, and things like that. If you like this video, please subscribe in my channel and see you in the next videos.